So this week we had a lot of questions about the bottle crops and how they grow. The first questions from the Oberschule am Wallering were about the lighting and the temperature we use to grow our bottle crops. Well, I will first answer about the temperature. I have a thermometer in the room, and right now it's telling me that the lab is at 18.9 degrees Celsius with 62% humidity. This means that my plants are growing at ambient temperature of the lab or of the habitat, depending on where they are. Then about the lighting conditions, well, here I have all the bottle crops I'm growing right now. These two were started on the 29th of April with the Ökonomisches Gymnasium of Bremen. And this one is growing under red and blue LED light, and this one is growing under natural light. So I'll show you. That's the red and blue LED, and that's the natural one. You can notice that I'll put them next to each other. You can notice the difference. This one looks a bit stronger and with more leaves than this one. It's getting more light. Then I have these three, which I started on the 5th of May with the three other schools of Bremen. This one is growing under white light. This one is growing under natural light. And this one is growing with ambient light of the hab. And you can see it's the weakest. Then I have another set of bottle crops. These ones. I only show you one, but I started three. I started them this week on Tuesday, the 13th of May. This is to compare with the 4th and 5th grader of La Grave, Villar in France. The Ökonomisches Gymnasium zu Bremen also asked if we had a theory of how plants will grow, and the school in France asked if the plants under the dome grow fast. Well, I think I've answered your question in the previous one with showing you the plants. Depending on the lighting condition, they are growing more or less faster. We hope to have edible plants, like a big lettuce, in about 6 to 8 weeks, and then we will consume the plants. Another question from the Ökonomisches Gymnasium zu Bremen was if there were already an experiment done with bottle crops before sending them here. No, there were not, because bottle crops are very recent, and they were not tested for analog space missions or space missions before. This is the first time, so you're participating in a first-time experiment. Well, it would not be exactly the same as here, because this habitat is conceived to be on Earth, so it's not pressurized, and we don't have thick layers of protection against radiations. But when we go on Mars, we will have to have a habitat which is made of materials which are resistant to the outer pressure, to the cold, and to the radiation. Most likely the habitat will be buried under Martian soil. So yes, there is water on Mars, and yes, there are clouds. They are really, really high in altitude, and they're mostly composed of ice crystals, like water ice crystals or carbon dioxide ice crystals.
There's two theories on how to get water to Mars. One is that you would bring it with you, so you would therefore store it in tanks and you would just ship it along with the crew. You'd have to keep it in a temperature controlled environment, so something that's not exposed to a lot of sunlight or exposed to a lot of the cold. The other theory is that we would extract water from the planet Mars itself. So you would send ships in advance of a human mission, and they would extract moisture from the air, or you could land them near the poles and they could then excavate ice and melt that down for human consumption.
Another way of transporting water on Mars would be to transport hydrogen, and then combining with the CO2 that we have on Mars. There is a lot of carbon dioxide on Mars, and this is called a Sabatier reaction, and the product of this reaction is water. So this will be a more affordable and lighter way of transporting water on Mars. The dome has two floors. The first floor is around 80 square meter, and the first floor is 40 square meter. So that's a total of 120 square meter for 6 people. Go.
Okay, so for the most part, we managed to get along with each other. Like anybody living in close quarters, like when you guys live with your families and your brothers and sisters and siblings, little stuff starts to get on your nerves occasionally. But the good news is we're all very compatible with one another, so we're easily able to talk back and forth, and little issues don't tend to become big ones.
As far as getting along with everybody, it's like any group of people. There's going to be disagreements and there's going to be things we need to work through, but it's nothing unusual, even in this environment. And I don't think that a real crew of astronauts would have a smooth relationship every day of the mission, but it's definitely something we can work with. As far as like room here personally, when I initially imagined being in a dome that technically has no corners, I thought that it'd never be able to be out of sight from another person, but there's plenty of space, particularly the fact we have our own crew bunk area. That there's been no problems with that.
So yes, I think we are a crew getting along pretty well. Of course, like any other group of people, we've been living together for 6 weeks, so of course there are some little problems sometimes. You cannot avoid that, but overall we are doing a lot of things together.
I wouldn't say it's defined, I think we're sort of flexible to the tasks as they come up. I try to manage my personal hygiene and my sports and fitness around the limitations we have, as well as the EVAs we do, so that I can both be clean and healthy and fit in within the schedule. I think that's sort of the challenge of the whole thing. Recreation. Yeah, as a crew, I think there's a little bit of a competitive streak amongst us all, so games are particularly interesting, card games, and some of the things we've done. Recreationally, I simply enjoy being able to watch a movie on the computer or reading a book. I've made through a handful of books so far, and it's nice to just be able to read for pleasure, which is something I don't get to do very often in my normal life.
In our free time, we try to play board games together, to watch movies sometimes when we have time, and we also have presentation night where one crew member gives a presentation about his or her topic of expertise to the other group, or about an experience we've lived, so that's really entertaining. Personally, in my recreational time, I try to read more than I read at home, and I write to my family and friends. I also try to do some sport. I don't have an actual defined schedule for working and doing sport, and anyway, the days we have EVAs, my schedule rotates around this EVA, but I try to wake up, work out, have a breakfast, then work on my research project, then have lunch, then work on my research project, or do some educational outreach or public outreach activities, and yeah, then working out again, then it's dinner time, and then again some work on the research, or if we have some spare time, a social activity with the group?
We do play games. We watch movies and TV shows. We're actually trying to do a pretend camping trip this weekend. So in our spare time, we try to get together and be as social as possible. For me, the routine really, because I'm involved in most of the EVA prep, my routine tends to be surrounded around whether or not we have an EVA that day. And I think it's true for most of the crew. If we have if we have an event where we're going to be exiting the habitat and we're going to be going out in the suits, that pretty much takes up a big chunk of day, and all food schedules, exercise schedules kind of get arranged around that. The rest of the time, it's a fairly typical pattern, and I think we all kind of have our own habits that we like. Some people prefer to exercise in the morning. I prefer to exercise late morning, early afternoon, and if I can do that, great. If not, I can always work out a little bit later.
Seven.
Well, I'm definitely starting to notice some changes in myself. I'm a little less tolerant than I was before. I'm definitely itching for some fast junk food. But for the most part, things are pretty much the same. I come from North Dakota, which is snowed in most of the time, so to me this just feels like an extended winter.
Well, I am eating healthier, living healthier, not I don't have access to the same bad foods I would at home, so I know that I've lost weight and become more fit. I have time to devote to fitness, which is really helpful, and in kind of a closed environment like this, it's harder to get sick, and I know that I showed up initially feeling unwell, but it's been a lot better since then, actually. Food is really tasty, which is incredible considering most of it's dehydrated, preserved, or desiccated in some way. I never imagined that there'd be this much variety in the things we could eat. That are none of it being fresh except for what we grow in our garden.
Speaking of food, is the food tasty?
I eat better here than I eat at home. The food here, everybody takes a little bit of extra time to prepare because we know that we're fixing food for everybody, not just for us. So we like it to be really yummy, and I have never eaten so well.
So the dome is located on Mauna Loa, on the Big Island of Hawaii. Mauna Loa is one of the 5 volcanoes of the Big Island of Hawaii, and it's considered to be the biggest volcano in the world. Now to answer the question about if it's warm in Hawaii, well, we are located at 2,500 meters altitude, so that's pretty high, and it's not very warm. It's like when you are in the mountains, in the Alps, for example, and you're at 2,500 meters, even in summer, it doesn't get that warm. So at nights here, it gets quite chilly, around 12 degrees Celsius inside. So no, I cannot say it's warm in Hawaii right now.
Well, it's fairly temperate in Hawaii. The temperatures stay between about 65 degrees Fahrenheit and 80 degrees Fahrenheit, which for you guys, I'm not really sure of the Celsius conversion. But it's up here on the slopes of Mauna Loa, it's a little bit different. It's kind of cooler in the evenings, and with the less atmosphere, the sun really beats down during the day, so it heats up quite a bit. Why is the water limited? Great question. On Mars, all the water there is either frozen or it's condensed in the atmosphere. There's very little water vapor present. So there's no liquid water. So any water is either going to have to be extracted from the ice, which is a very energetically expensive process, or it's going to have to be brought. And water is a very, very heavy commodity. So any water that we bring would have to be reused and recycled in the Martian environment. So here we're simulating that. We have very limited water usage, just like you would expect on the Martian planet, because they only have so much water that they brought with them. Well, for me, the water limit really hasn't been too much of an issue. It's mostly with our hygiene routines that it's affected. We only get 8 minutes of showers a week, which sounds like quite a limited amount, but when you really break it down, it ends up to about a couple minute shower every other day or so. And it hasn't been too bad so far.
Word limit's not bad. I can't lie, having a nice warm shower is an incredible blessing, and I look forward to it every other day or so. But that being the case, it has to be every other day or so because of the limitations we have. And I think that while there's a number of ways we can improve, it's not a bad system altogether, and it's nothing to complain about.
One of the questions we got from the French school was, how did you get the idea to grow plants on Mars? Well, the idea is not mine. The idea comes from the 70s, more or less, when scientists were wondering how we could sustain humans for longer periods out of the Earth. Well, what you have to consider is now the astronauts on the ISS get resupply every 3 months, more or less, resupply of food. When we have people on the Moon or on Mars, knowing that to go on Mars it takes approximately 8 months, we won't be able to send regular cargoes of food to Mars for the astronauts. So the solution the scientists came up with is that astronauts have to grow their own food, and so grow plants to survive. Indeed, you can bring seeds with you, and they don't take much space, and you can grow them and then have seeds again and grow them again and have a cycle like this. Another question from the French school was, will you go to Mars one day? If so, when, and how long will it last? Well, NASA is planning on sending people on Mars between 2030 and 2040, but the mission is not totally planned yet, and the team which will go there is not formed. So the mission, like the stay on Mars, on the planet, will vary between 1 month and 2 years. This will depend on the alignment of planets to make the return to Earth easier. So as I said, the team is not formed yet. We don't know who is going to go to Mars. Of course, if they would ask me, I'd say yes right away. I am 28 years old.
I'm 33 years old.
Ross, how old are you?
I'm 28.